Well, let's talk about probably the most interesting object I've heard about and also the most fun to pronounce.
Oumuamua, yes.
Oumuamua. Can you tell me the story of this object and why it may be an important event in human history? And is it possibly a piece of alien technology?
Right. So this is the first object that was spotted close to Earth from outside the solar system. And it was found on October 19th, 2017. And at that time, it was receding away from us. And at first, astronomers thought it must be a piece of rock, just like all the asteroids and comets that we have seen from within the solar system. And it just came from another star. I should say that the actual discovery of this object was surprising to me because a decade earlier, I wrote the first paper together with Ed Turner and Amaya Moro-Martin that tried to predict whether the same telescope that was surveying the sky, Pan-STARRS from Hawaii, would find anything from interstellar space, given what we know about the solar system. So if you assume that other planetary systems have similar abundance of rocks and you just calculate how many should be ejected into interstellar space, the conclusion is no. We shouldn't find anything with Pan-STARRS.
To me, I apologize, it's probably revealing my stupidity, but it was surprising to me that so few interstellar objects from outside the solar system have ever been detected. Or none has been. We'll maybe talk about it, that there has been one or two rocks since then.
Well, since then there was one called Borisov. It was discovered by an amateur Russian astronomer, Gennady Borisov. And that one looked like a comet.
Yep.
And just like a comet from within the solar system.
But this is a really important point, and sorry to interrupt, that you showed that it's unlikely that a rock from another solar system would arrive to ours.
Right. And so the actual detection of this one was surprising by itself, to me.
Yes.
But then, so at first they thought maybe it's a comet or an asteroid, but then it didn't look like anything we've seen before. Borisov did look like a comet. So people asked me afterwards and said, doesn't it convince you, if Borisov looks like a comet, doesn't it convince you that Oumuamua is also natural?
Yeah.
And I said, when I went on the first date with my wife, she looked special to me.
Yes.
And since then I met many women.
Yes.
That didn't change my opinion of my wife. So, that's not an argument. Anyway, so why did Oumuamua look weird?
Yeah.
Let me explain. So first of all, astronomers monitored the amount of sunlight that it reflects.
Yeah.
And it was spinning every 8 hours. And as it was spinning, the brightness that we saw from that direction, we couldn't resolve it because it's tiny. It's about 100 meters, a few hundred feet, size of a football field. And we cannot, from Earth, with existing telescopes, we cannot resolve it. The only way to actually get a photograph of it is to send the camera close to it. And that was not possible at the time that Oumuamua was discovered because it was already moving away from us faster than any rocket we can send. It's sort of like a guest that appeared for dinner, and then by the time we realize that it's weird, the guest is already out the front door into the dark street.
Yeah.
What we would like to find is an object like it approaching us, because then you can send the camera irrespective of how fast it moves. And if we were to find it in July 2017, that would have been possible because it was approaching us at that time. Actually, I was visiting Mount Haleakala in Maui, Hawaii, with my family for vacation at that time in July 2017. But nobody knew at the observatory that Oumuamua is very close.
That's sad to think about, that we had the opportunity at that time.
Yes.
To send up a camera.
But don't worry. I mean, there will be more. There will be more because, I operate by the Copernican principle, which says we don't live at a special place and we don't live at a special time. And that means, if we surveyed the sky for a few years and we had sensitivity to this region between us and the sun, and we found this object with Pan-STARRS, there should be many more that we will find in the future with surveys that might be even better.
Yes.
And actually, in 3 years' timescale, there would be the so-called LSST. That's a survey of the Vera Rubin Observatory that would be much more sensitive and could potentially find an Oumuamua-like object every month.
Yes.
Okay, so
Wow.
I'm just waiting for that. And the main reason for me to alert everyone
Yes.
to the unusual properties of Oumuamua is with the hope that next time around, when we see something as unusual, we would take a photograph or we would get as much evidence as possible. Because science is based on evidence, not on prejudice. And we will get back to that theme. So anyway, let me
Yes,
point out
some
what
of the
is
properties, actually. Yeah,
Yes.
the elongated nature, all of those
Right.
kinds of things.
So the light curve, the amount of light, sunlight that was reflected from it was changing over 8 hours by a factor of 10, meaning that the area of this object, even though we can't resolve it, the area on the sky that reflects sunlight was bigger by a factor of 10 in some phases as it was tumbling around than in other phases. So even if you take a piece of paper that is razor thin, there is a very small likelihood that it's exactly edge on. And getting a factor of 10 change in the area that you see on the sky is huge. It's much more than any. It means that the object has an unusual geometry. It's at least a factor of a few more than any of the comets or asteroids that we have seen before.
You mentioned reflectivity, so it's not just the geometry, but the properties of the surface of that thing.
Well,
or no?
If you assume the reflectivity is the same,
Okay.
then it's just geometry. If you assume the reflectivity may change,
Yes.
then it could be a combination of the area that you see and the reflectivity, because different directions may reflect differently. But the point is that it's very extreme.
Yes.
Actually, the best fit to the light curve that we saw was of a flat object, unlike all the cartoons that you have seen of a cigar shape. A flat object at the 90% confidence gives a better model for the way that the light varied. And it's
so
also
like flat, meaning like a pancake.
like a pancake,
Yeah,
exactly. So that's the very first unusual property. But to me, it was not unusual enough to think that it might be artificial. It was not significant enough. Then there was no cometary tail. No dust, no gas around this object. And the Spitzer Space Telescope really searched very deeply for carbon-based molecules. There was nothing. So it's definitely not a comet the way people expected it to be.
Can you maybe briefly mention what properties a comet that you're referring to usually has?
Right. So a comet is a rock that has some water ice on the surface. So you can think of it as an icy rock. Actually, comets were discovered a long time ago, but the first model that was developed for them was by Fred Whipple, who was at Harvard. And I think the legend goes that he got the idea from walking through Harvard Square and seeing during a winter day and seeing these icy rocks, And
so a comet is icy, and an asteroid is
it's just a rock.
It's just a rock.
Yeah. So when you have ice on the surface, when the rock gets close to the sun, the sunlight warms it up, and the ice sublimates, evaporates. Because the one thing about ice, water ice, is it doesn't become liquid if you warm it up in vacuum, without an external pressure. It just goes straight into gas. And that's what you see as the tail of a comet.
Wow.
The only way to get liquid water is to have an atmosphere like on Earth that has an external pressure. Only then you get liquid. And that's why it's essential to have an atmosphere to a planet in order to have liquid water and the chemistry of life. So if you look at Mars, Mars lost its atmosphere, and therefore no liquid water on the surface anymore. I mean, there may have been early, and that's what the Perseverance survey, the Perseverance mission will try to find out, whether it had liquid water, whether there was life perhaps on it at the time. But at some point it lost its atmosphere, and then the liquid water was gone. So the only reason that we can live on Earth is because of the atmosphere. But a comet is in vacuum pretty much, and when it gets warmed up on the surface, the water ice becomes gas, and then you see this cometary tail behind it. In addition to water, there are all kinds of carbon-based molecules or dust that comes off the surface.
And those are detectable.
So it's easy to detect. It's very prominent. You see these cometary tails that look very prominent because they reflect sunlight, and you can see them. In fact, it's sometimes difficult to see the nucleus of the comet because it's surrounded and shrouded with, and in this case, there was no trace of anything.
That's fascinating.
Now, you might say, okay, it's not a comet. So that's what the community said. Okay, it's not no problem. It's still a rock, it's not a comet, but it's just a rock, bare rock.
Yes.
Okay, no problem. Then, and that's the thing that convinced me to write about it. And then in June 2018, significantly later, there was a report that in fact the object exhibited an excess push in addition to the force of gravity. So the sun acts on it by gravity, but then there was an extra push on this object that was figured out from the orbit that you can trace. And the question was, what is this excess push? So for comets, you get the rocket effect. When you evaporate gas, just like a jet engine on an airplane, a jet engine is very simple. You throw the gas back, and it pushes the airplane forward. That's all. That's how it. So in a case of a comet, you throw gas in the direction of the sun and then you get a push. Okay. So in the case of comets, you can get a push, but there was no cometary tail. So then people say, "Oh, wait a second, is it an asteroid? No, but it behaves like a comet, but it doesn't look like a comet. So what? Forget about it. Business as usual."
So that's what they mean by a non-gravitational acceleration. So that's interesting. So like the primary force acting on something like just a rock, like an asteroid, would be like you can predict the trajectory based on the gravity. And so here there's detected movement cannot be accounted purely by the gravity of the sun.
And if it was a comet, you would need about 1/10 of the mass of this comet, the weight of this comet, to be evaporated in order to give it.
And there was no sign of that.
No sign. 10% of the mass evaporating, it's huge. Think about it, 100-meter size object losing 10% of its mass. You can't miss that. And
so that's super weird.
It's super weird.
What is there a good explanation? Is there in your mind a possible explanation for this?
So I operated just like Sherlock Holmes in a way. I said, okay, what are the possibilities? And the only thing I could think, so I ruled out everything else, and I said it must be the sunlight reflected off it. Okay, so the sunlight reflects off the surface and gives it a push, just like you get a push on a sail on a boat, from the wind reflecting off it. Now, in order for this to be effective, it turns out the object needs to be extremely thin. It turns out it needs to be less than 1 millimeter thick. Nature does not produce such things. But we produce it because it's called the technology of a light sail. So for space exploration, we are exploring this technology because it has the benefit of not needing to carry the fuel with the spacecraft. So you don't have the fuel, you just have a sail, and it's being pushed either by sunlight or by a laser beam or whatever. So perhaps this is a light sail.
So this is actually the same technology with the Starshot project.
Yes. So
that's fascinating. Okay,
people cool. Afterwards say, "Okay, you work on this project, you imagine."
No, that's a pretty good explanation, right?
Obviously, my imagination is limited by what I know. So yes. I would not deny that, working on light sails expanded my ability to imagine this possibility.
Yes.
But let me offer another interesting anecdote. In September this year, 2020, 2020,
yes.
There was another object found, and it was given the name 2020 SO by the Minor Planet Center. This is an organization actually in Cambridge, Massachusetts, that gives names to objects, astronomical objects found in the solar system. And they gave it that name 2020 SO because, it looked like an object in the solar system, and it moved in an orbit that is similar to the orbit of the Earth, but not the same exactly. And therefore, it was bound to the sun, but it also exhibited deviation from what you expect based on gravity. So the astronomers that found it extrapolated back in time and found that in 1966, it intercepted the Earth. And then they realized, they went to the history books and they realized, oh, there was a mission called Lunar Lander Surveyor 2 that had a rocket booster. It was a failed mission, but there was a rocket booster that was kicked into space. And presumably this is the rocket booster that we're seeing. Now, this rocket booster was sufficiently hollow and thin for us to recognize that it's pushed by sunlight. So here is my point. We can tell from the orbit of an object. Obviously, this object didn't have any cometary tail. It was artificially made. We know that it was made by us. And it did deviate from an orbit of a rock.
Yes.
So just by seeing something that doesn't have cometary tail and deviates from an orbit shaped by gravity, we can tell that it's artificial. In the case of Oumuamua, it couldn't have been sent by humans because it just passed near us for a few months. We know exactly what we were doing at that time. And also it was moving faster than any object that we can launch. Yes. And so obviously it came from outside the solar system. And the question is, who produced it? Now, I should say that, when I walk on vacation on a beach, I often see natural objects like seashells that are beautiful, and I look at them, and every now and then I stumble on a plastic bottle, and that was artificially produced. And my point is that maybe Oumuamua was a message in a bottle, and we should this is simply another window into searching for artifacts from other civilizations.